Good morning.
Hello.
Hello, can you hear me okay?
Yes, I can hear you. And
Right.
yes, let me find out the posters here.
Hey, good morning, Kamal.
Is it the correct room we are in? I mean, we are in poster room 4, right?
Correct.
Yeah.
I have 2 presentations.
Oh, yes, Martin.
Yep.
Yeah.
This is a lot of organization for you folks, right?
I think it's more work for the ASSW organizers. I'm only moderating this session.
Yeah.
So not much on my side, but yeah, lot of Zoom work. And I think too many Zoom meetings, parallel sessions. Yeah.
Yeah. It's quite a bit.
Yeah, it's quite a bit. Yeah. I'm not sure. I should have 2 volunteers in this session, but I'm not sure. Is there anybody who is volunteering for this session as the Zoom technicians or volunteer?
There's a link on yours. Hold on one sec.
We still have 2 minutes, so we still wait for a few more, and we'll start on time at 2.
Very good.
So can you see the screen for the first poster?
Yes, we can.
Yes. So we totally have 10 posters and 9 speakers.
Should I start now? Because this is my poster.
Okay.
All right.
Or our poster.
I would guess so.
Yeah, I
Yeah.
think it's 2, and I think we should start on time. So let me introduce myself. I'm Sridhar Javak from Svalbard Integrated Arctic Earth Observing System. I'm based in Svalbard in Longyearbyen, and I would be moderating this session with the 10 posters, and we would have a really fruitful discussions after each poster. So everybody will have 2 minutes, 2 to 3 minutes to explain the poster, and then we will discuss over the poster one by one. So I would first invite Olga for presenting her poster. Olga, are you ready?
Yes, I'm ready. Can you hear me?
Yes, and I have shared your poster on the screen.
Yes, that's right.
Yep.
So hello, everyone. My name is Olga Pavaraznyuk. I'm a postdoc researcher from the University of Vienna, and I will be presenting this poster on behalf of also my co-author, Peter Schweitzer from the same university. And Peter is also present here to answer your questions. My poster is called Transportation Infrastructures and Development, Tracing Socioeconomic and Climate Change in Tixi and Bykovsky, Northern Russia. And this poster is part of the research conducted under the frameworks of a large international UN project, Permafrost Thaw and the change in Arctic coast, Nunatak. Our case study area encompasses 2 communities, Tixi, a port city along the Northern Sea Route, and the indigenous village Bykovsky in the Republic of Sakha-Yakutia in Russia. The case study focuses on the relationship between transportation infrastructures, permafrost thaw, and community development in the context of the state modernization program of the Northern Sea Route. Our main research question is how do permafrost thaw and reconfiguration of transportation infrastructures affect economic activities, quality of life, and population dynamics in these 2 communities, and how do local residents react and adapt to these changes? In July 2019, we conducted anthropological fieldwork, including participant observation, interviews with residents and experts, as well as archival works that yielded the following preliminary results. The town of Tixi still continues to be that was founded back in the heyday of the Soviet development of the Arctic, still continues to be an important especially strategically important transportation node in the context of the current modernization program of the Sea Route. However, the bulk of foods and goods are supplied to the community from other locations by the Lena River from the Uskut city in another region, and also by the winter roads from the city of Yakutsk, the capital of the Republic of Sakha-Yakutia. This reconfiguration of the Soviet supply system due to curtailed state support and impact of permafrost thaw that we see on the seasonal on the example of the changing seasonal winter roads cover resulted in increase of consumer prices in both communities and decrease of living standards that in their turn also resulted in population outflow. The growing coastal erosion in the due to the effects of the permafrost thaw is especially evident in the village of Bykovsky, and it severely affects subsistence activities, transportation, infrastructure, and mobility in the village. These problems, however, are overshadowed by even more urgent socioeconomic concerns that are connected with the reform of the Soviet kolkhoz system that resulted in unemployment and overall decline of the community in the post-Soviet period. On the photos below, you can see the erosion of the coast in Bykovsky, and also you can see a means of transport, such as this motorboat that serves as the main transportation means between Bykovsky and Tixi by sea in summer season. Yeah, we'll be happy to, I think my time is over, so we'll be happy to answer your questions. Any questions about methods or contents of the poster?
So any questions to Olga on this poster? If not, then we can go for the next poster. Thank you, Olga, for your presentation.
Thank you.
Yeah. So the next poster is by Alice Miller Hooks. Are you here? Alice, are you here for the presentation? Seems not. Okay, so I think Alice is not available for the presentation, so we should move to the next presentation. There are two presentations by Martin. Okay, Martin, are you ready for the presentation?
Sure. That's item 4, and I don't mind going out of order if that's how you have them. I'll start with this one.
Okay.
So we're trying to inspire the next generation of Arctic observers. And by doing this, we've been working, and I particularly have been working with an NSF grant for the past 3 years. This was around the International Polar Year, to gather Inuit traditional knowledge, mostly from the high Arctic of Eastern Canada and Western Greenland, and collected about roughly 10 communities, 4 elders identified within each community, and basically broadened the sense of traditional knowledge for narwhal. I'm a narwhal researcher. I'm a dentist by profession. I teach both at Harvard Dental School and Case Western Reserve. And I'm also on staff at the Smithsonian. So have this combination both of anthropology and science, and have noticed that over the years, in being introduced to traditional knowledge, you have to wait typically till you get to a graduate degree before it really comes as a serious science. And because of that, the focus was really to get children involved, particularly high school kids, but even younger, to understand that our framework is really only one framework. Western science typically being used in many studies, particularly of narwhal that I was doing, can oftentimes be misguided. There was a recent paper just out associating tusk size with narwhal size. It got a lot of press. It's just recently out there. It's only been published and released for about a week or so. I was asked to review it, but it's an example typically of researchers that did not do their homework with regard to Inuit traditional knowledge. They basically showed that the larger the whale, the larger the tusk. And that's not true for many narwhal, which they didn't include in their sample. So for example, the largest male narwhals, the bull narwhals, have no tusk. So there goes the theory right there with bull males. And females also have tusks, and males and females can have 2 tusks. So the idea is, well, how do we get scientists to be sensitive to traditional knowledge? And this work is really focused on finding ways. I don't know if you can lower the poster. Do I do that on my side, or? I tried scrolling, but it doesn't really work for me. There we go. You can go down a little further even. So the idea was to create a hybrid program between STEM and traditional knowledge. And we call it iSTEM. It includes many of the United Nations Sustainable Development Goals, as well as the symbol that you see in the center there, the I standing for Inuit directly, and also integrated because we're combining both the science and the Inuit perspective, as well as indigenous, to see the Inuit as one of many indigenous cultures around the world and how we can implement this program. So this is the program we're actively involved with. You'll see some of the graphic novel we just released there, Transformed by a Tusk, to get people engaged and to find ways to link science and traditional knowledge to educate the next generation. And I have time for questions. I think that's roughly 2 minutes, so.
Yes, that's really interesting, Martin. So this poster is open for the questions or the discussion. Anybody from the audience, would you like to know some more information about this poster? So if not, then I have a question for
There was
Martin.
a question on the chat.
Okay, let me check out.
Gabriel Vance asked, could you please say more about the graphic novel?
Yeah, absolutely. We just released this. I actually have a copy next to me I can show you, but the graphic novel was really to illustrate many of the concepts that we're trying to get to with this next generation, to involve them a little bit more. But basically, Eco Hero, who's riding a unicorn in this case, is meeting science. And the idea is that along their path, they meet elders, Sangalak, and a daughter, Suyuk. So she and the elder are all involved in this novel. And it goes through the combination of how important traditional knowledge is. So there's an Inuit legend of the narwhal, for example, that is within this graphic novel. And also some of the more modern concepts, because now Arctic is really the focus of natural resources and tourism, all sorts of impeding influences that are going to change the face of the Arctic. And so these are brought up as well. And in this case, the narwhal in the graphic novel are asking for help from Eco Hero, as opposed to superheroes who are always, you know, killing off their enemies. Eco Hero is really centered on saving the planet and finding ways to amend certain disagreements between cultures in this case, and to find ways of balance. And at a time of COVID-19, I can tell you, I as a scientist think that much effort has to be focused on how we live on our planet. This is not something about a vaccine that's going to stop a virus. This is a much larger issue that has to be dealt with. How we deal with animals, how we deal with cultures, how we deal as a society with living more peacefully and integrated with our own planet.
Thank you. Another one was coming from Kamal. In what language is the program going to be delivered to the kids?
Kamal, greetings to you, my friend. Kamal's from the Museum of Nature in Canada. He's a curator of vertebrates and zoology there. Language-wise, I have just gone up to the Nunavut Research Center up in Iqaluit in the Canadian High Arctic, and they immediately want to see this translated into Inuktitut, which I think is great. So for now, it's in English. We're hoping Inuktitut will be the next language, and certainly open to other languages. French is obviously another one on the list, but for now, we're just releasing the English version, and then we'll take it step by step. But certainly the Inuktitut is already on par.
Excellent. Any more questions to Martin on this poster? Okay, I think we can move for the next poster by Martin. Oh, it's the same. Okay, Martin, the floor is yours.
Yeah, this is probably one of the most important storytellers in the Inuit tradition. This is Cornelius Nutarok. He was given the Order of Canada. He was given the Elders Recognition Award in 1999 within Canada. And I remember meeting him in 2003. And I've been working in the Canadian High Arctic for 20 years now with elders. I was given a 3-year NSF grant to collect this knowledge. Cornelius obviously was the most important person as far as I was concerned, although they all were important for an interview. And in fact, when I met him first, I looked at my photographer who had been with me on 4 of the expeditions, and I looked very sternly and said, this is likely the most important thing we may be doing up here in the next years. And having looked at it retrospectively, it was. I was able to collect Cornelius's notes. His son, Jaco, who is on this poster. These are residents of Pond Inlet, a town I have worked primarily in for probably about 10 of those 20 years. And collecting the knowledge from Cornelius in the first interview was quite expansive. We spent roughly about an hour and a half. So I have broadcast quality and WAV files of his interviews, and they are in repositories for safekeeping since now, with his passing in 2007, these are valuable notes. And also with the Nunavut Research Center up in Iqaluit, we are working currently on a book of his notes. So it took me roughly 5 years of working with Jaco Alulu, his son, to acquire permission for his notebook. And I had seen the notebook, and Cornelius had shared it with me during the interview, but I didn't have a chance to actually physically have the book or copies of its notes. So I inquired for Jaco. I always brought him gifts every year I went up, because it's a matter of trust for the Inuit, and understandably so. We don't always represent the kindest faces when we're visiting. So after a while, I had gotten permission, and then I invited Jaco to the 2012 Inuit Studies Conference held at the Smithsonian. Greetings to Bill Fitzhugh if he's out there, and also Carol Bossert, who are from the Smithsonian, and wanted to tell Jaco if he could bring the book with him, because he didn't want to send it by mail. So he brought the book with him. I, in the meantime, wasn't sure if it was actually coming, but called the Smithsonian Archives, which typically you'd have to wait months to get permission and authorization for, but they had just acquired a new machine, and they said we could do it as a test case. And it was great. So we got the notes accomplished within several hours. All of them were digitally archived from the Smithsonian, and working with the Nunavut Research Institute now, translating them. And the wealth of knowledge in Cornelius's notes is easily worth my 20 years of going up there and getting information. So these are incredibly valuable pieces of information that we're hoping to dispense and process with an outcome of having a book likely done in both Inuktitut and English on his writings. If there are any questions, happy to.
Any questions to Martin? Yes. When do you expect publication?
You know, the largest bottleneck with this kind of work is the translation work. This is typically where most of the time, energy, effort, and finance actually take place. So I'm hoping for a 2-year outlet from today's date to actually have it on a shelf and in a form that is purchasable. Yep.
Okay. And one more question. What are some important takeaways of the upcoming book? Could it also become a graphic novel?
It could become a graphic novel, and it could be integrated in that form. Certainly if the one that we have is successful, we'll continue that route. I know they were very excited at the Nunavut Research Institute and said these kind of books fly off their shelves. So I think some of the takeaways that are interesting is, again, the kind of knowledge. So for example, if you look in a book of marine mammal biology, you'll see listings of narwhal that are nowhere near as integrated and defined as the ones that the Inuit have. So you'll see that list kind of in the center now, and then a little bit to the right on that side is also some of the breakdown of anatomical classifications. So you can see the listing of how detailed they are. And not only are they very detailed, but they're extremely accurate. So they know anatomical differences between male and female tusks. They know all the behaviors. They can even tell the difference between different different classes or subspecies, if you will, of narwhal. So they can tell the difference in behavior between a Greenland narwhal and a Canadian narwhal. They know the migration patterns if one visits the family or population of another. The Greenland narwhal are a little bit more bulbous in the front and the tail slenders more than typically more Canadian narwhal, which are more slender throughout the body. If you look at tusks, female tusks typically will get more, how would you say it, more deposited in the center portion where the nerve is earlier than males will. Keep in mind that tusk has an innervated nerve from its base all the way to its tip. They even know the behaviors and patterns of where different groups of narwhal are. So for example, in the much higher Arctic, above Pond Inlet, these are now at the northern tip of Baffin Island, there's another group of narwhal with a smaller, wider tusk that they also identify by region. So it's very important and critical to gather this information for science. And there's no better animal in terms of the narwhal or metaphor in terms of taking Inuit traditional knowledge and bringing it to a larger group than this type of animal to illustrate. So that's why we chose traditional knowledge and science linked with iStem through the eyes of a narwhal, and getting some of this perspective from both sides and both knowledge frames to be able to address it.
Fantastic. I think I have one more question from Kamal. He mentions that he has the double tusk narwhal in the collection, perfectly symmetric. How important is this kind of specimen to Inuit?
Oh wow, it's a gem in Inuit culture. Certainly, the narwhal is already regarded as, you know, almost an animal that they worship. Really, that's part of the reason why the Inuit legend of the knowledge, Inuit tale of the narwhal evolved basically because of how important this animal is. And certainly if one catches a double-tusked animal, this within the hunting culture is regarded as the apex. Also interesting, because when we talked about the paper that was just released about tusk size and narwhal size, I commented on double-tusked narwhals because I thought, well, geez, if you have two tusks, are you going to be double the size? You know, because according to their theory, that's what you would have. So this is why listening to these voices is so critical in science. And it's throughout the world, really. It's important to talk to your neighbor. It's important to talk to the people who know some of these animals the best.
Fantastic. So I have one more question, Martin, for you. Will your participant receive a portion of the profit from the book for his compensation?
The compensation for this book will go to Jaco's family. That's the decision that we've decided to make. Certainly within larger references like this, they're not money-making exercises. These are really more from passion and concern for sending a message really to a larger audience. And because this is really the story of the narwhal told by the people who know it best. We have the filter and lens of scientists, but how wonderful it's going to be to get it right from a source. And this is what I would consider a source. And likewise, I think any benefit from that source should go back to the source. So we see profits from the book going back to the family of Cornelius Nuderak.
Fantastic. And Marty, you have got a compliment that this notebook and deep understanding of the narwhal through observation is very impressive. Well, thanks for your really interesting presentation on this topic.
Yeah, thank you for listening.
Yeah, any more questions to Martin? Seems not. So thank you, Martin. I will move to the next presentation. I think we have, I just want to make sure that whether Alice Miller-Hooks is back and you are able to present now. If not, then I will move to my presentation.
I'm ready if you want. I just couldn't figure out how to unmute.
Okay.
Sorry about that. Good morning.
Good
or
morning,
good
Alice.
afternoon or good whatever.
It's afternoon here anyhow. So, okay, so can you see your poster here on the screen?
Yeah, thank you.
Okay, yes.
Okay, so I'm excited to talk about our almost new project from the National Science Foundation. It's one of the larger ones and gives us an opportunity to try to do something kind of big. And so we want to try to do it right. We are working on a project called an Expanding Global Maritime Network. It's Arctic Impacts and Reverberations. You'll see we have a number of researchers coming from a variety of different areas. I won't go through the names, you can see them on there, but their areas also align with the different thrusts so that you can see how this all comes together. If you don't mind going to the bottom of the poster. Way at the bottom there is, keep going further. So you see the project overview. So we have 5 different thrust areas, and I'm gonna try to just run through them quickly. But basically the idea is that we want to create the capabilities in mathematical modeling and geophysics and computational and social systems to understand how changes in the Arctic, how the melting of the Arctic passageways will affect world trade flows and supply chains around the globe, and will increase risks to the Arctic's natural and social ecosystems, and also issues of conflict and governance. If you could go up just a hair, I want to start with thrust 1, which is just above that. Sorry, I didn't realize how this would be presented. So here you see, go down a little. Can you go back down? So you'll see there's a thrust 1, maritime flows. So everything ties together around the maritime flows. The idea is that as those passageways open, become more amenable for transport, that cargo flows are more likely to, many of them are more likely to take those routes. And that is because for certain origin destination pairs, this corridor is a much shorter passageway and can save a lot money-wise if is passable, but that it's becoming increasingly passable. So as the traffic shifts into this area, you're going to see more development of infrastructure to support those passageways, and ultimately, we know from the transportation world that we have a supply-demand relationship, and this grows. So with that, we will have increasing opportunities in the Arctic, both for exploration and exploiting the resources, and different governments vying to have a piece of that, which will lead to potential conflict. Thrust 5 on the left, you'll see that we're developing a conflict early warning system and indicators of conflict. So that is one of the thrust areas to understand that. But we also need to understand what it means to build in a melting Arctic. The infrastructure that would support these flows, for example, the Port of Nome could be made larger, and deep draft and so forth. It's built on permafrost, and as permafrost is melting, or roadways, ice roadways are melting that allow access to some of the resources. How do you actually build structures on a melting permafrost, and how much melt can we expect? In addition, as you pass through the passageways, we need to understand the ice conditions. We know that even the melting of the ice can cause greater icing for the ships. And so we want to understand the risks for shipping. And then so that you'll see the thrust, if you go up just a hair on the poster, can you go up just a little bit, just a little higher? The other way, sorry. You go up a little to the top, toward the top. Oh, there, stop. So there's ice physics. So we have ice physics work that we're doing, and hydrodynamic works, and and trying to understand how to, well, first we're developing models that can help us predict, and then trying to understand how this will affect the ships, the shipping equipment, and other infrastructure. We're also looking at the coastal dynamics and how that is changing as we have greater, a changing landscape, and how to predict some of these things, and then the effects on the local communities. So we're take a stand in any direction, but rather trying to understand just how things will change and what kind of effects they'll have. So from a local community perspective, we're engaging the communities to work with us and trying to understand the risks, the benefits, the opportunities but the issues, and we're looking at ways to try to mitigate some of the concerns that they have. So we work in particular with folks in Utqiagvik, Alaska, or Barrow, Alaska. And one of our team members, Anne Garland, has been staying out there about 3 months a year for many years and has been doing a lot of work there. If you can go all the way to the bottom, I'll just wrap up. So you'll see as this is a National Science Foundation project, we have a number of activities that are educational as well. We have summer camps out in Utqiagvik and some other areas in the North Slope. We are working with early career researchers, and we do outreach through ARMNet, which is part of ARIES, where Anne Garland is, where we're looking at scenarios and workshops and webinars and so forth. As a team, we'll host 2 workshops over the 5 years of this award, one on conflict avoidance in the expanding Arctic, and another from the infrastructure or civil engineering side for cold weather environments. And then we are doing community-based monitoring. We have quite a number of different monitoring systems up in Utqiagvik. I believe Anne is at this conference too, and we'll be talking a little bit about this as well. So we're looking at coastal erosion, surge barrier, and so forth, and then tundra green engineering of surge berm barrier, harmful algal blooms that could come from a warming water and also from the ships that are going through their illegally releasing their waste, and also on permafrost and thawing. So it's a big project, and we're trying to bring all these things together. Last thing I just wanted to mention is in my own part of the work, which is on the routing piece, where we're looking at the maritime flows and how the flows will shift as we have new opportunities for different routes. We are studying the data. We're trying to study the data about the cargo shipping across the globe. We managed to get 6 weeks of worldwide AIS hub data on every vessel that you can see on that through that data stream. And we got it from the middle of February to the end of March. Actually, today's the last day. And it's a kind of interesting time to have gotten it. We have every 15 minutes, we know where every vessel is that can be on a beacon, that's where the beacon is within range. And we're going to try to understand what happened just because we happen to get this data at this time. We're going to try to understand what happened during the supply chain sort of closing down due to the COVID-19 event that's ongoing. So with that, I end I wrap up here.
Thanks, Alice, for interesting presentation. And I have a couple of questions for you. First, by Sandra Starkweather.
Sure.
What are the time frames of the decisions that are supported by this work? More decadal infrastructure scale?
So mostly we're looking at longer timeframes, but I mean, longer from my perspective. I work in disaster management primarily, and in that area, I look at like days or hours. In this work, we're looking more on the order of maybe a year, years kind of thing. Not decades, but more like from year to year kind of changes, and then looking forward into decades. Because obviously we're trying to understand the ice melt over a long period of time.
Okay, and there is one more question for you. Could you specify which disciplines are involved in the project? What are the expected outcomes, and how exactly do you involve local communities?
Okay, so that's a lot of questions I hope I can remember them all. Okay, so first we have, I'm a transportation engineer and work in civil infrastructure systems. So I do optimization, mathematical modeling, that sort of thing in civil engineering type applications. Others in the group are, we have another civil engineer who works on the coastal dynamics and green engineering. And another person, so that's Celso Ferreira. We have Thomas Ravens from the University of Alaska at Anchorage, who works and is leading the effort related to the ice forecasting, meteorological conditions, and structures and building structures on a melting permafrost. And we have Jinlun Zhang, who is at the University of Washington, who is in the area of ice physics and has developed tools for forecasting icing and things like that, and of that nature. Anne Garland is at Aries. It's a nonprofit, and she's the person I mentioned who's been living out in Utqiagvik 3 months a year, and she's set up most of the monitoring. And Tom, she works closely with Tom Ravens as well, so he's also worked on some of the monitoring with her. She's a social scientist or anthropologist, so she's coming at it from a community perspective, and she's engaging the community in most of the activities we're doing out there, from the summer camps and risk. She's running discussions or kind of like interviews of local people related to risk and risk management. We also have Sarah Cobb at George Mason University, where I am, who is in conflict analysis and resolution. So she's working on that aspect of it. And then we have Ralph Punt, who is a captain of, he has captain ships through the Arctic, and he teaches courses on how to do that at the Maine Maritime Academy. So he sort of checks us in terms of what we're modeling. Are we doing it well? Do we understand the risks? Do we understand, like, you know, the what's on, you know, sort of the way that this would actually work? There's something else I was going to say. So you asked me about
the I think you have covered the disciplines which are involved in this. So what are the expected outcomes of this activity?
Right. So one overarching outcome will be a toolbox, which we hope to put out to everybody to use. So we've started by creating a global model of the maritime network, which hasn't been done before, to include most of the world's largest ports, and to allow modelers to look at these things at a global scale. And then we're developing mathematical tools that others can use to assess various scenarios and how the trade flows will shift. We're going to generate scenarios that we believe are important to study. We're developing a conflict early warning system to detect and indicate and identifying the important indicators of conflict to help detect when something may go awry, so that we can try to get ahead of it from an international perspective. You know, there's a lot of interest in the Arctic across numerous countries, not just the Arctic countries. We hope to include that in the toolbox, and we also hope to include the tools that we're developing, like the Arctic version of what's called X-Beach, and other tools for the meteorological estimates and the coastal dynamics portion. So we hope to put all of this into a giant toolbox for the world to use. That's our goals. And of course, to gain insights by studying these things. For example, in trying to understand how the world's supply chains, like where you resource from, will change if your routes change. So how will these things shift? What does it mean for different countries?
Okay, and the last question on this sequence was, how do you involve the local communities in your project?
Right. So at this point, we've got Utqiagvik involved. We have monthly meetings, and their emergency managers attend our monthly meetings. We had hoped to have a team go out there this summer so that we all could get familiar with the conditions out there and get to know the people out there. Of course, that won't happen this summer, but hopefully soon for all of our sakes. All of us have been talking with folks around the globe, and had a number of trips plans that we had to cancel, but to meet with people who are doing work like this, so that we can better understand how to make these things as useful as possible and to understand the environments. We welcome everybody to come work with us and to help us get involved. And one of the reasons I wanted to attend this conference and share this project with everyone is that we do have time to make those connections and to participate with others and have others participate with us. So we really want to be networked and to be as helpful as we can with this project.
Thanks for the answers. And I think you have a couple of more questions, and it's One of these is, how do you integrate this work with officials who are designing master plan for the respective communities?
Very big question. The first thing is we build it and we put it out there and try to show some use cases. Beyond that, that's outside my area, but I would say that Anne has connections in the local community that we can use to work with them and start there. And since they are working with us, they can help us try to make it as useful for these folks as possible. And then Sarah is working with people from all over the world in studying the narratives and so forth in developing these indicators. And I'm hopeful that she'll make some of those connections and also be able to get the feedback to help make what we do as useful as possible.
Okay, and I have a question from Miko. Are you connected with us, with the Arctic Council Working Group on Emergency Prevention, Preparedness and Response?
I think, this is something that I could use some help with, and maybe Miko's can help me on the side. I believe I signed up for it, but I don't know what to do with it. So I'm struggling to understand how to get connected, even though I think I'm officially connected, but I don't know how to make use of it. Maybe some of the other team members have done better than I have in that regard. But if you could write to me, maybe we can have a discussion offline.
I will. Thank you.
Yeah, thank you.
Okay, and two more questions from Martin. One is anyone from your team addressing the noise pollution impact to marine wildlife?
I wouldn't say that we have a noise expert, and right now we're not monitoring that, although I think that may not be so major now. It may be in the future, and it's definitely something we've talked about. I mean, we are so ARES does a number of other studies out there, and I know from talking with the emergency managers that they're very aware of the effects that some of the traffic has on the wildlife in the water. So they've been watching that. They share some of the information with us about that, but we haven't officially been looking at that.
Okay, and is the study limited to the US? And if extended to Canada, how does this project interface with the Inuit land claims?
Okay, so we are not necessarily forced to stay to the US. We can go beyond. We hope to go beyond the US. We are looking at this from a global perspective. I am not familiar with the Inuit land claims, so I'm not sure what that is, so I can't really speak to it. And I'm not sure what that means for our project.
Okay. Martin, do you have any more comments on that?
No, just that many indigenous people have been given sovereign rights to their land and how it's used. So part of the Inuit land claims is to identify people, Inuit in Canada anyway, who have rights. I mean, who have decision making and come to the table basically to make decisions and can deny shipping. They have a different situation than other regions around the world. So Canada has implemented this part of diplomacy to give Inuit voices a little bit stronger claim to how their land is used.
You know, this sounds like it would be very important for Sarah Cobb, the person working on the conflict analysis, to look at. I wonder if I could put her in touch with you just to get her connected if she isn't already.
Yeah, I know most of the people that are involved with it. Their center and headquarters is in Iqaluit, Canada, but depending upon who you talk to and what communities, you know, for example, the community of Arctic Bay has prohibited shipping traffic through Admiralty Inlet. And part of the reason why I addressed the aspect of noise pollution was because of how that impacts other communities that shipping has been involved with. So I think once communities identify the loss of certain species because of this, they are all interconnected, certainly. And within the high Arctic, they're all interconnected globally. So their communication standpoint, I think from a center point, like this land claims office, might be important for you folks.
So I can't see who's talking. Did I catch right? It's Miko?
Oh, Martin, sorry.
Martin, okay. All right, I'm gonna send you a quick email just to put you in touch with Sarah as well. I think this is really important. Thank you. This is exactly why I wanted to attend this conference, so I can learn more and meet you folks.
Cool. And Alice, you have last questions about, could you speak a bit more to the demand supply interactions in the maritime flows impact model and the methodology behind it?
Sure. So that's the one thing I know more about because that's my group. So we are actually developing a mathematical model of global shipping for cargo, both bulk and container shipping. And we've identified and plotted the majority of the ports that we want to work with, and about 85% of the cargo flows that we know used to exist before the COVID virus. And so we started trying to get the data from the AAS Data Hub for global shipping because we wanted to try to calibrate the model so that we could estimate how much flow would shift over to shorter routes. So if we understand the utilities that folks are using right now, we'd be better able to understand how they might shift to something that has a shorter distance. But the models are right now deterministic. They will include risk. So we'll be trading off risk of different routes. And I don't know what else to say about it. The decisions that will come, the decision variables are about the flows along the different shipping lanes. And so we'll have a better feel for like where the shipping will move. And one of the things I believe is that as the shipping routes, the flows change to alternative routes, they, where you source your raw materials or parts may change because it may be better for you to move to, I don't know, a different area in China, or you may not need the transshipment that is offered at in the Singapore ports, which are, I'm very familiar with Singapore in general. I work with their ports, and so just to use them as an example, they handle about so they're the number 2 port in the world by volume. They handle, I think 85% or 88% of their throughput is from transshipment, which means that you're just, sort of moving things around, but you're not generating your demand from there. You're not sending any, all that much there. So if that's their business and the routes change, there's going to be maybe a shift away from Singapore, which could affect their economy. So that sort of thing is the kind of thing we want to be able to predict from these models and try to understand how the new routes will not just shift the trade lanes, but also will shift things that are happening in the countries that are supported by these routes. I'm not sure if I answered the question, but ultimately these are mathematical models. They'll be stochastic. They'll handle some of the underlying uncertainty. I don't know what else to say about them.
Marina, do we have any quick questions on this?
No, thank you. That was very informative.
Okay, with this, I think we have no more questions, and thank you, Alice, for this such an interesting topic, which actually gave birth to the discussion.
Oh, thank you for having me. I'm so glad to meet everybody. I wish I could meet you all in person.
Okay, so with this, I will move to the next presentation. I think this is me. Okay, so I would be speaking more on the how to involve, or what is the motivation of the non-Arctic nations in involving into the observing system. So I would start with the SIOS. So what SIOS is, the Svalbard Integrated Arctic Earth Observing System. And it's based on the research infrastructures developed by different institutions from the different countries who are active in the Svalbard for research purpose. And we have very well developed research infrastructures in terms of the research facilities and the instrumentation, which are carrying out the continuous data collections. And we also try to make this data available through our SIOS data management system. So why Svalbard is very high Arctic and is a regional observing system. And there are rapid changes in the temperatures which are faced by the Svalbard and which are recorded now. And that's why it's very highly important to study those changes with this kind of observations and the observing network. So we based on the our work, the total work is based on the involvement of the members. So in SIOS, the member institutes are the members, not the nations. So in each country can have more than one institutions which can who can be a member of the SIOS. So if you can see on the poster, so and the map, you can see that the involvement of the different nations. First of all, we have 2 Asian nations, the Japan and India. We have 3 Arctic nations who are involved in SIOS, and we have 4 European non-Arctic nations which are involved. The institutions are involved in this observing network. So, so what we are studying for a long time with the response what we receive from our member institutes during the entire year of practicing. So these are some of the key points what I would like to highlight. What is the motivation of these members to involve in the observing system is they have their own national and common interest. The national interests are, and some of them are common to the other countries or the other nations who are working on the Svalbard. And they believe that the concept of SIOS and its contribution in collaboration. So we also facilitate the collaborations between the institutes in terms of funding, in terms of the proposal writing and the projects. So we try to involve these collaborations, and also in the data, what is derived from the this infrastructures are made. We are making it available through SDMS, which is available to the whole research community. So we try to optimize the usage of these research infrastructures through collaborations. And also we provide some logistics services for the easy access and the some of the supports when you are in Svalbard for the field campaigns. And this is also motivations when you are in Svalbard. If you are looking for logistic support, such as the facilities for the boat or the sharing space in helicopters or using the aircraft-based imageries, this kind of supports are possible through SIOS. And the most important is about why engagement of the non-Arctic nation is the scientific belief in long-term tangible benefits of sharing data, knowledge, expertise, and best practices within the network. And that's the most important motivations we think that the SIOS member institutes feel. And more on that, SIOS also enhances the opportunity for common funding applications. For instance, there might be a call between the Polish-Norwegian or the Indo-Norwegian or the bilateral benefits of the funding application. So SIOS also enhance this kind of opportunity. So every member gets benefited individually by getting the funding, and also they also involve in the group activity as SIOS does. So these are some of the motivations what we have identified with the experience with the SIOS. And these are our members. You can see the logos down there. And I'm happy to answer the questions if you have questions on this poster.
Hello, this is Pamela Peters.
Yes, Pamela.
Can you scroll up a little bit again in your poster? Decrease the environmental footprint of science as an environmental economist. That absolutely interests me. Can you expand on that, please?
Yeah, sure. So what we try to reduce is environmental footprint and the human footprint. So what we do, we co-locate the instrumentations. For instance, if we have the permafrost boreholes and the co-located with the weather stations. So when you are going for the maintenance of this, both the infrastructures, so we are reducing this by placing it or co-locating this infrastructure in Svalbard. So this is one way we do it, co-locating the infrastructure. Also, we also use the modern technologies such as using the drones or the aircraft imageries, where you don't have to visit much into the places, and you can still receive the data sets. So this is the one of two things. One is technological, and one is the co-location of the infrastructure. That's how we work on that.
Okay, thank you.
I think I have some questions from the chat box. Could you repeat the main research question? So the research question is about, this poster is not about more on the research, but it's our experience on how, what is the motivation of the non-Arctic nations to get involved into the observing system, such as which is working in the Arctic or the regional system in Svalbard. Because the SIOS works most towards the Earth system science questions, and most of the motivations come from the majority is the science-driven involvement from the members. So this is the motivation of the poster. And I have one more question. I think, what are some examples of best practices that have enabled investigators? Yes, so the best practices, one of the success story of the SIOS is the shared knowledge is about the CES report, the State of Environmental Science in Svalbard. So this is the annual product we produce, and you can actually get the copy of this from the SIOS website. And this is the best practice because this is the wheel of the SIOS. So where every member institutes or the authors, they try to find out what are the gaps or the lacunas in the current knowledge, and how do we actually use this in the next year of the development of the observing system. So this is one of the things. And if you go to the SIOS websites, again, we have started in this kind of difficult situations when the field campaigns in Svalbard are not sure because of the travel restrictions now. So in addition to the regular services, now we are providing the remote sensing services where we can patch up the field campaigns data sets. What you are going to miss, we are going to try to patch up with some of the field values we can patch up with the remote sensing activities. Also, we are going to provide the access to the research aircraft where you can get the imageries, hyperspectral data for your studies. So we provide the support to the scientists and based on the situations. And that's the best practices what we have now as the success stories for the moment. Okay, so I don't have more questions on the chat box, but still, if you have more questions, I'm ready to answer now. Okay, I think not. So I think we can move forward to the next presentation. Thomas, are you there?
Yes, can you hear me?
Yes, I can hear you.
Can you hear me?
Yes, I can hear you.
Great. Okay. Yeah. Okay.
So this is your poster.
Yes. Can you just? Oh yeah, that's fine. So hi everyone. I'm from the Joint Research Center of the European Commission, and this poster summarizes the key outcomes of a study which we recently finished at JRC. The study aims at evaluating how the EU's space capabilities in 4 domains, basically Earth observation, navigation, communication, and space situational awareness, can benefit the Arctic in various fields, whether it's environmental safety or security needs, for example. The space situational awareness in this context refers mainly to space weather. So what this study does, it reviews key EU policy actions for the Arctic and space, and it identifies then various Arctic user needs, which you can see on the left side, which have been categorized from science users, from operational users, and also indigenous and local community users. These user needs were gathered from various surveys conducted by other projects, in particular, for example, Horizon 2020, Arctic-related projects, which have ongoing activities with Arctic communities. For scientific users, the outcome was also used from the so-called Polar Expert Group, which was put together last year by the Commission to basically do a gap analysis for the Earth observation part. So they first did a scientific user needs survey to understand better what will be needed over the next 10 years or so in the Arctic. Then compiled basically an inventory of present and future planned space capabilities across these 4 domains: Earth observation, navigation and communication, and space situational awareness, space weather. The focus is on Copernicus and Galileo, the major space programs of the EU, but contributing missions and services from non-EU organizations are also included. And in the end, it identifies various synergies which can be exploited across the 4 domains and discusses 2 concrete examples. In the middle, you can see the current missions and services for Earth observation. So these are on the left side, mainly Copernicus, of course, with the Sentinels, and then various services which produce products from the data from these satellites, plus using also some data from other missions which are listed in the other columns from ESA, EUMETSAT, and also non-European satellites. And then the future missions which are discussed in this report are the so-called 6 Copernicus high priority candidate missions, of which 4 are listed here because these 4 are more Arctic oriented. I mean, in principle, you can use all 6 of them for the Arctic, but these 4 have been specifically designed and suggested to be included in the next space program because they are current issues of stability and continuity over the next 10 years. After 2030, we are expecting to have the so-called next generation Sentinels, but the issue is that we need to cover the period until then, and these Copernicus high priority candidate missions are supposed to cover this gap in terms of increased resolution, increased revisiting time, deeper penetration, for example, for an active synthetic aperture radar sensor, and other issues. And on the right side, you see this brief discussion of current and future navigation services provided by you, which is the Galileo service, and also a brief discussion of the communication services, while the Earth observation and navigation Galileo services are quite sophisticated. Let's say the communication part is really lacking in the space program so far. The major Arctic-related global, let's say, or covering the whole Arctic system is the Iridium system, and there are some other satellites which can be used for, especially the Argos system for some non-continuous satellite communication. And then space weather is, of course, particularly important for the Arctic, not only for the Arctic, but particularly there could create problems regarding communication infrastructure and smooth functioning of society in the end, because so many things are depending on telecommunications and connected issues. And so for the next space program, which hopefully will be adopted this year with a new finance plan of the European Union, the anticipation is that there should be also some additional communication and space weather projects within this new space program. But of course, we don't know until it actually has been approved. We are relatively confident that the Copernicus expansion missions will be, to some degree at least, be included. And then further down on the poster, there's a discussion of certain synergies at service and infrastructure level between the navigation, observation, and communication services, how they can be used together and how they interact with each other to provide specific services which are particularly relevant for the Arctic. And two specific synergies are discussed in the lower, in the middle column at the bottom of the poster. One is the so-called Genesis reflectometry, which basically uses signals of opportunity from navigation satellites, for example, Galileo, to retrieve a large range of parameters relevant for the Arctic, which can be soil moisture, sea ice thickness, and so forth. And that is basically a combination of Genesis, very cheap passive Genesis payloads on satellites to receive these reflected navigation signals off the surface. And then this data is then also combined with additional Earth observation data to generate new insight into some of these parameters. And another synergy example would be automatic identification system for ships. And this could be, for example, combined with synthetic aperture radar satellite images, which could detect ships. And if you then see from the combination of the AIS signal and the SAR satellite images that these ships have actually turned off their AIS broadcasting signals, then there could be a hint that they are engaged in some type of illegal activities, for example, illegal fishing activities. So this could be used as a useful synergy, for example. And that would conclude my overview of the poster. Thank you.
Thank you. And I have a quick questions from the audiences. Any recommendations? I have a question from the audience. Miko asked about any recommendations on how Earth observation data will be easier to utilize from this study.
Okay. It was not specifically discussed in the study itself, but we had some separate discussions on this. And one issue with the data is also there's a huge amount of Earth observation data. A lot of it is not, let's say, easily available, let's say through some data portals. There's currently something being built which is called the DIA Center, the Data Infra. I think it's called the acronym stands for DIA, Data Infrastructure something. I'm not sure. Sorry, but anyway, so they are currently building this infrastructure where a lot of this data will be offered to the more general public in a heavily processed way, easily downloadable, and you can also upload your own, let's say, scripts to calculate whatever you would like to calculate, but it will also offer certain, let's say, services which can be then easily just retrieved from these web portals. Again, they are not completely finished. Some of the services are already available, but it will still take some time to offer the full access to the data which is produced by the satellites.
Thank you. And I think I have two more questions for you. The first one is, how does your group prioritize and decide which investigations are considered for the space monitoring?
For which? For?
Which investigations are considered for space monitoring? How do you prioritize this thing?
Again, that comes from the user service. We know that from the service what the operational centers need, what type of variables are needed by the science users. And so then from that, we also understand, okay, in order to fulfill these needs, you need a higher resolution in order to, for example, track icebergs on an operational basis. We need to improve the resolution by this. We need this type of instrument. And this is exactly what came out of this other report, which I mentioned from the Polar Expert Group, specifically for Earth observation, which made then these recommendations for these high priority candidate missions. So again, it's all based on some type of service and talking to different types of users. I would say that overall the input for the definition of these HPCMs was mainly coming from the science and operational users. I don't think that the survey results from the indigenous and local community users has been, at least not in the past, been really had a big impact on these decisions. It's more like these results were more used in the analysis what could be done with the data once the data is available.
Okay, and I think these one more connected questions by Martin. Which variables such as ice, water temperature, sudden weather shifts are you able to study with regard to the marine mammals and ocean flow patterns?
For the marine mammals and ocean float patterns?
Yeah, ocean flow patterns, yeah.
Oh, flow, oh, sorry, okay. Marine mammals, I'm actually unsure. I'm not really knowledgeable enough about this specific topic to answer that. For the flows, so for the ice, the ice flows, I assume, right? So if the question is related to ice flows, then we have
alert from System UI server.
I'm sorry, what? I couldn't hear you.
Martin, can you speak again?
Yeah, it was from the ice flow, but I was also concerned about water flow patterns. If there's any detection you can do from space with regard to flow patterns.
Like river flow patterns, or like just in general water coverage on land.
Yeah, water coverage, but also you know, the Arctic Ocean in particular is a little bit more dynamic, huh? Because you've got the sub-Atlantic waters and you've got the Arctic Ocean on top. So if there's...
Okay, so you're also talking about ocean currents, basically.
Correct, correct.
Okay. I think, okay, I would have to get back to you specifically for that question. I remember that some of the, at least HPCMs, would have capability to detect currents, but I would have to check it again to make sure that I give you the right answer. So if you, yeah, I would have to send you a message later on it.
Yep, that would be great.
Mm-hmm. So you are, sorry, your name was, so I would find you.
I presented on the third and fourth poster there. So
oh, yeah, okay, yeah. I see you there. Okay, thanks. Mm-hmm. Mm-hmm.
Yeah, I think there's Miko has commented on already. Currents are coming from the Copernicus Marine Environmental Service, utilizing the sea level measurements from satellite. So I think this is the answer to Martin's question. I think if you are using the Copernicus Marine Environmental Services, you might be able to get some information on that.
Right.
it might be possible. I would have to check what is in detail currently available.
Okay.
Well, there is current information in this Siemens service, and it is really using different, so the topographic or the, well, sea topography missions are made for this, and that information goes into models to give it then over the whole ocean information.
Okay, great.
Great.
Great. And I think I don't have any more questions, but I still have a quick curiosity questions that looking at the today's situations about the virus outbreak, and we are facing the situation that most of the travel, because of most of the travel restrictions, the field scientists who would be missing their in situ measurements in Svalbard or in the rest part of the Arctic. So are you or the European Space Agency, or do you have any plans to go some extra mile to reach to the users and provide more data, or how to patch up those field or in situ data sets with the space-based measurements? Do you have any upcoming plan for this?
Not specifically on a short-term scale, which would, let's say, deal with the coronavirus crisis.
Okay. Okay, then no more questions. Then I will go for the next presentation by Gabriele. Are you ready for this presentation?
Yes, I'm here. Can you hear me?
Yes. And I would quickly open your poster. Yeah. Can you see that poster on the screen?
Yeah, I can see it.
Yes. And the floor is yours.
Okay, perfect. Thank you very much. So today I'll just spend a few minutes giving an overview of how the Canadian Arctic Weather Science Project SuperSite help us facilitate weather-related decision support in the Arctic. So I work for Environment and Climate Change Canada, so for the Government of Canada. Weather is a safety issue for the Arctic with hazardous conditions including blowing snow, blizzard, fog, and extreme cold. And if we can see on the top left figure, blowing snow and blizzards are the second most common weather events in Iqaluit. Blizzards can affect navigation, safety, and mobility for search and rescue operations in the Arctic and for people that live in the area as well. As population, economic development, and tourism continue to grow in the region, demands will be placed on transportation and star-related infrastructure and services. And such activities may be compromised by extreme weather conditions, creating an important need for the accurate monitoring and prediction of Arctic weather. So if you scroll down a little bit on the poster, one initiative, can you lower a little bit the poster just so that we can see the bottom, please? Thank you. So on the bottom left, one initiative from the Government of Canada is the establishment of enhanced meteorological observation sites in order to test new technology for the monitoring of atmospheric conditions. The sites are located in Iqaluit, so the bright star on the image, Nunavut, and Whitehorse, Yukon, the leftmost star on the bottom left figure. As part of the Canadian Arctic Weather Science Project, also known as CAWS, C-A-W-S. So each site is equipped with state-of-the-art instruments providing a wide range of near real-time meteorological and measurements autonomously and near real time. So the instruments there operate without any support from humans. So if I'm located in Edmonton, so I do have access to all our measurements in near real time through a data portal that you can access with the QR code there. So to date, the CAWS project has been used to test new meteorological technologies in Arctic conditions. So research into the future operational monitoring and forecasting program. So if you scroll just back up a little bit on the poster to go on the top right, one of the things that we look into is to add on to our network of radiosondes, so the weather balloons that are launched to get vertical profiles of temperature, wind, and humidity. So we have been testing LiDARs and water vapor LiDARs and radar technology to see if they can operate autonomously through the entire year with very little human support and on-site support. The second thing that we've been done with the CAUSE project is to enhance the understanding of polar processes so that we can better represent them in numerical weather prediction systems. So on the right panel, the middle, with understanding the polar processes with our instrument, the Ka-band radar, we have been able to document the presence of alternating wind layers of alternating speeds and direction that changes with height. And we have been able to document that over a period of 2 years. And as these layer events can impact the meteorological conditions in the region, also for aviation forecasting and numerical weather prediction forecast system, then our next step is to determine if the models have the ability to accurately represent them. And then the third thing that I wanted to highlight in this poster is that through the CAUSE project, we have been able to develop and test weather products relevant to Northerners to support adaptation and mitigation with respect to hazardous weather. So if you again scroll down just a little bit on the poster so we can see the lower half, thank you very much. One of the products is a blizzard forecast projects that's shown in the bottom right, and our Iqaluit field site provides critical observations for the verification and the development of blizzard and visibility forecast. And these products are extensively used by our operational weather forecast program and services. They've also been used with the Department of National Defense, with their Arctic exercises. They've also been used for North Pole expeditions and also by search and rescue operations. And as a general conclusion, the tailoring of the meteorological information to users and stakeholders is a value-added service that's essential to maximizing our weather forecast effectiveness at influencing preventive behavior. And that's where we want to get to. And so the key for success will be to develop a mechanism to successfully integrate what's scientifically possible and technically feasible with what is socially desirable and supportive for Indigenous peoples and communities, Northerners, SARS officials, and local governments to make a project that's primarily scientifically driven to have a greater impact for adaptation and mitigation in the North. With that, I just wanted to highlight that if you do access the poster, you can scan the QR code and it will lead you to our projects data portal where you can have access to the different data that we have, but also additional information on the instruments and contact information if you want to have access to more data, if you want to learn more about our projects. So thank you very much.
Thank you, Gabriela. That's for your interesting presentation. So in audience, do you have any questions for Gabriela? I have one question, Gabriela, about the blizzard forecasting products. Are you providing this near real time, and what is the methods to, how do you reach to the users of these products?
Yeah, thank you very much for the question. So this blizzard forecast product is an experimental product that's developed by a researcher at Environment and Climate Change Canada. And the way it works with the workflow of how we get the data and the products to the users is that this data is primarily used by operational weather forecasters as an added information to what they already have, which will then help them create better alert warnings and forecasts. But we also have a set of users to which are provided with some of the images. And on our data portal with on ecpass.ca, you can actually access some of the blizzard forecasts for the Iqaluit area. example I've shown here was just for the Iqaluit area because it's around one of our super sites, but those products are actually available for the entire Canadian Arctic domain. And beyond the blizzard forecast products, we have also a fog and stratus forecast product for level clouds for navigation and airport forecast.
Yeah, thanks. And I have questions from the chat box. Are you cooperating in this project with other Met offices in the Arctic countries?
So this one, the research and development is primarily used with only Environment Canada, but we have been involved, we're involved with the Year of Polar Prediction. So the COS super sites have been used for international numerical weather prediction model evaluation studies as well. And so, yes, we are cooperating with other Met offices with this. I just didn't highlight our international contributions with this project, but those sites are part of the YOP verification sites.
Good, thanks. And I think, are you also focusing with the space agencies to use the super site as the calibration validation site?
Yes, absolutely. We're using those sites for the AOS, the wind, and also for the GPM, the Global Precipitation Measurement websites. But that is not quite my area of expertise. So if you did want to learn more about how our sites contribute to satellite CalVal, please don't hesitate to send me an email and I'll redirect your question to a member of my team.
Thanks for this, but I have one more question about the alternative technologies testing. So what's different into this kind of technologies? Is it new technology or only reducing the human footprint on the observations?
So it's both. Some of the technologies that we've deployed had not been deployed in the Canadian Arctic for a full year. So when we're talking the K-band LiDAR or the different LiDAR, so we're testing technologies that are not part of our operational network. So they may have been deployed in field campaigns, but we're actually testing their viability with little human footprint and also their performance at sustaining a full Canadian winter with very cold temperatures, high wind, and no sun.
That means it also reduces the maintenance of the weather station.
Yeah. So one of our goals was to have as little human interaction with the instruments as possible, because, as you know, it's quite costly to conduct Arctic field work, and so to test technologies to look into developing new network design. If we did want to expand, then it would only be sustainable if we didn't have to visit the sites periodically. Yes, that's correct.
Okay, thank you. Any more questions to Gabriela? So let's start with the next presentation. It's by Alison Gaylord. Are you there?
So Allison's not able to make it, but as a co-author, I could present.
Okay. So can you introduce yourself?
Great, thank you. So the Arctic Research Mapping Application, or RMAP, on the left, and the Arctic Observing Viewer, AOV, on the right, are applications, web mapping applications and services that support Arctic science. RMAP on the left tracks over 3,000 field-based research projects funded by the US National Science Foundation, as well as 17 other agencies and organizations. RMAP is mainly about US funded projects, a little bit more. And then AOV on the right encompasses over 32,000, here, let me do this. Okay. Over 32,000 observing sites, observing assets, specifically observing sites with details and precise locations for individual monitoring assets across 35 observing networks. And that AOV is broadly international in scope. And so together they convey the who, what, where, and when of Arctic research and Arctic observing, respectively, with links to data and more information. The new RMAP 3D viewer on the left provides custom navigation, multiple high-resolution base maps, and advanced visualizations. And then just yesterday, actually, we released a prototype of a new AOV 3D viewer online. Both apps also display ship tracks, medical facilities, observatories and stations, and more. So the team behind these we're dedicated to information sharing with open web services, such that anyone can access those data services to populate their own databases or for their own portals, and that does happen, and as well as documentation to improve interoperability across platforms. So in sum, these apps and their underlying databases are designed to help science planners, logistics managers, data specialists, research scientists, and others to assess status, identify overlap, and fill gaps, to facilitate coordination, for access to data, and clarify directions to better meet scientific goals. Thank you.
Thank you, William, for your presentation. And any questions for the William? Okay, I think if not, I have a quick questions about these observations sites. So are all these data sets are harvested from the different data centers, or do you have any other mechanism to read all these data sets?
That's a good question. So each one of those yellow dots on the right, for example, is an observing site, and not exactly a data set. So there's higher order details in the table there, or you can search and filter on, or with different fields within the database, if you will, different details about each observing site. And that site could be a platform or an instrument or whatever. And so this information is kind of, it's beyond the data set level. And a lot of this information is not available in data set level metadata, if you follow me. And so it's something that different networks or observing systems, there are different portals, and some of them release information in compatible ways with these details. But a lot of it is actually manual data wrangling and screen scraping to pull together this information. And because we're not able to get everything that we need from data repositories, and so there is a separate poster, actually, that if people are interested in the interoperability of information about monitoring assets like sites or stations or tracks or systems, there's a separate poster on a new working group that's just starting up under the SAN Committee on Observations and Networks. And feel free to look at that poster and also click on the link on the poster to sign up for this new working group to make it easier for everyone to build site level databases and to share compatibly that information.
Okay. Thank you. And let me check if I have some questions on the chat box. Seems not. Yes. So thank you for your presentation.
Thank you.
So the next presenter, Dimitri, are you there? Dimitri, are you there for the presentation? Seems not. I think I will go for the next presentation. So this is the last presentation. Brigitte, are you there?
Yeah, I'm there. Thank you.
Yeah. I hope I pronounce your name correctly.
Brigitte, but it's fine. I'm used to it. I'm used to it. So yeah, maybe let me first introduce myself because I'm new in the Arctic scientific community. So I'm a project scientific officer at the Joint Research Center of the European Commission in Italy. And since about last year, I've been investigating the potential of existing Joint Research Center products and methods for the Arctic. And in this first poster are illustrated some of the results of the analysis of 4 globally harmonized datasets of the Global Human Settlement Layers projects. So our colleagues at the GRC have built those datasets. The 3 first one, which are analyzed here, are 1 by 1 kilometer gridded information of buildings, population, and degree of urbanization, which have been derived from the Landsat imagery, 40 years of data, and built into 4 time periods individual datasets centered on 1975, 1990, 2000, and 2015. And I also had a first look to urban center database, which is somehow derived from the urbanization information. And this database consists of 28 indicators covering geography, socioeconomic, environment, disaster risks, and SDGs dimensions for more than 10,000 cities, 5 of which are located in the Arctic domain as defined here in our study. And to define this Arctic domain, we have merged the 3 AMAP, ADHR, and CAF domains, which are being developed and used by the Arctic Council working groups. If you can go down to the poster, please. So we have, perfect. We have analyzed this data from regional to national, administrative, and local levels in terms of population dynamics, point 2, in terms of settlements and changes in settlements, point 3, in terms of degree of urbanization, point 4, and for the last data set, I just presented here some example of indicators, exposure indicators or resilient relevant indicators. So the current developments, if you go down to the end of the poster, thank you. They include the combination of this information with other gridded data for the long-term integrated monitoring of human and environment exposures to various risks. And that is the final aim of our study, for the definition of Arctic-specific resilience indicators using, where possible, a social ecological system approach. Well, that's it. And if you have any questions, please just do.
Any questions for this presentation? I know it's a long session, but still we have some more courage to ask some questions. How do you define resilience? This is a question from Olga.
There is the definition is the one that has been set in the framework of ARAF. That is the assessment of, Arctic Resilience Assessment Framework of the Arctic Council. I don't know it by heart, but it's about the coping capacity and how also they can adapt after the disaster, the hazard. If you want, I can send you the official definition, but it has evolved in time. And I can give you the last version by email if you want. It's not a specifically original one. I know that there is not one universal, so it has been set up by the Arctic Council. Sorry for not being able to tell you by heart right now.
Okay.
Any other question? We don't see Norway in figure 5. No, in fact, key end means Kingdom of Norway, and the same for Denmark because of the Iceland. So it's not the Norway only; it's the whole territories belonging to Norway.
Okay.
Any other questions?
I think there is no more question. But thank you for presentation. And I think it was the last presentation, but I have got one more request from the room too, by Pamela Peters, whether she can present her work here. So I think we still have a time. So I would ask Pamela Peters, are you ready for your presentation?
I am. Do I put the video on, or we're just going to see the poster?
It's a poster.
Perfect.
You can see on the shared screen. And
excellent.
Let me know if you want to move the poster up and down. Yeah.
Okay. Well, I'm a storyteller, so it's going to be a blend of both. Thank you foremost to everybody involved here. This is a wonderful Plan B. And thank you also for being an amazing moderator. As an environmental economist specialized in sustainable development, I'm bridging the economic reality as we know it with the reality of our planet through different tools. TV productions, I'm an author, so I release books and educational courses since 20+ years. Since our planet is showing many signs of imbalance and the Arctic poles are hit twice as much and influenced twice as much as other parts of the world through climate change, to create the next generation of Arctic observers is going to be a very, very important task. So this proposed study basically wants to integrate the Inuit way of knowledge and science from iSTEM, which is Inuit STEM. And we have created a new integrated approach to teach students in the secondary school system. What is important to know is that in the US, for example, 50% of kids in high schools are not exposed to studies related to environmental education that focuses on climate change. So we really try to solve an imminent problem. We all know that Richard Lew says, if you don't know about the planet, you will not care for it, therefore not invest in it. So this particular study is going to result in a hybrid where we're gonna blend the integrated Arctic knowledge and the science the way the Western world knows it. We are going to create a test with 200 high school students, both in Canada and America. We are having several outputs. Of course, as a producer, we're going to create video modules. We're going to have educational modules. And then we are going to have a case study that is centered around the narwhal. Of course, I hope you enjoyed the 2 contributions of Dr. Martin Nuia previously. And I will be heading for the 3rd time with Dr. Nuia to the Arctic this August to continue expanding on the interviews. And also based on his 20-year-long expertise on the narwhal. That's going to be a fascinating study for youth. We are going to include United Nations sustainability goals 4, 5, and then 8 to 17. And we hope that we are going to not only inspire the next generation of Arctic observers, but also put all these kids to work. And that's basically at the cornerstone of one of my more important curriculum, Become an Eco-Hero, that I have been developing since 9 years and is currently integrated in 10 countries. And that is a little bit the poster. You see a lot of Dr. Nowia's research, where he has interviewed many elders from 10 communities. And the revolution, I would say, in education, with what you have been doing here with the distant learning. So the video courses are going to be accessible very, very easily. And I hope that, you know, youth from the Western cultures are gonna be fascinated by a blended model where traditional knowledge is going to show a much broader reality than what they are used to. My approach is always holistic, and maybe I have more of an inkling to the indigenous way of looking at the environment, which is absolutely a broader approach, an integrated approach, where we not only focus on one variable, but interact with the entire environment. Thank you.
Thank you, Pamela, for your presentation. And I think we still have a time for questions. So if you have quick questions, feel free to ask. In short, I have seen really good 2 or 3 posters on novel studies. I think, Martin, can you summarize all these posters based on your poster and the Pamela's poster now?
I think the real summary is, as Pamela has indicated, to understand that science really is reductionist. We're concerned about really one variable, and we sometimes miss the larger contextual part of science, which can be wrong. And Inuit traditional knowledge is very contextual. So they see everything within their observation. So for example, if they were to see a behavior from a marine mammal, they would describe it in very contextual terms. They would tell you the weather, they would tell you the conditions, they would tell you that maybe they've only seen it one time, but they're very accurate. And people have asked in science, well, how do you know how dependable those variables are if they can't be repeated? Because naturally, science is predicated on the hypothesis and repeatable results, and with large samples. And the best answer I ever heard was because their life depends on it. Their observations are based on survival. They can't afford to be wrong. And every one of the statistics I have seen that have come from an Inuit presence. I'll give you one example, but we were told early on, and if anyone has ever seen a narwhal tusk roughly 8 to 9 feet, you would think that thing is very rigid, can't bend at all. And we were told by a couple of Inuit elders that that tusk has an ability to bend and flex 12 degrees in every direction. I was up there in the high Arctic with the director of, it was formerly the Paffenberger Research Center at the National Institutes of Standards and Technology, an expert on dental materials and quite a few other materials besides dental. But we both looked at each other and thought it was not even plausible. We went back and analyzed the narwhal tusk tissue and found it was the most flexible and strong combination material on the planet, and that the Inuit were indeed correct in their perception of its flexibility. So these kinds of perceptions are extremely important, and we need to train a new generation of scientists not only to be sensitive to Inuit knowledge and maybe acknowledge them in a footnote, but do as we have done from the inception of the research to create Inuit partners. They are on most of the publications I've done. So if you look at most of the publications I've done, roughly 20 or so, Inuit authors are always present. And I think it's important for the international there's an international description of what is required to be an author, and the Inuit and Indigenous are certainly not a part of that, which is why in the Canadian system, which I applaud, they have taken Indigenous people and many Inuit as consultants or as reviewers, or certainly taken their input on the same level as scientific input. And I think this is an important thing for other systems to adopt as well. So really the overview is taking traditional knowledge and science and showing the benefit of both frameworks to all cultures.
I see
Thanks,
there's
Martin.
another question.
Yeah, Mamela, can you answer these questions from the chat box?
Yeah, sure. It'll be my pleasure. Well, I've been interviewing people thanks to my first TV show, Our Planet, since 2001. So I have a very, very easy way to approach a person. And the last expedition that I joined was in Pond Inlet in Baffin Island. I just approach youth. The first time I went into a classroom situation. And I basically interviewed children through the concept of making art about our planet and then go deeper. This was a younger audience. My last expedition, I approached children that I met through visiting families. It's wonderful in the Arctic. Everybody in the evening just jumps into another living room. Everybody knows each other. What they're doing is really strengthening the community daily. They talk a lot and they exchange a lot of information. So as I walked in living rooms, I saw 3 children here, 5 children there, started talking about the planet and just said, let's go outside and make a video. So these are very sweet approaches to getting youth already excited, you know, to talk. Can you talk about your environment? And to older ages, I said, well, what did you know about nature? They were talking about the fact that the fires in Canada, they could smell at certain days, they could smell the smoke of the fires. So it's a total different approach of gathering information, which is very organic, and that's the only way. Of course, we'll prepare questionnaires ahead of time as well. As I said, we're using my eco-hero model, which is using 4 ecosystems, where we look at the state of the environment, the causes of disintegration, and then also resulting to the fact of not just creating Arctic observers, but also Arctic restorers in a possible, you know, perfect situation. Wouldn't that be great? Then we go into the inroads into job opportunities as well. And now we're gonna link that with the narwhal studies of Dr. Nuia. And then the challenges with engagement. I don't have challenges with engagement. My love and passion is noticeable by all, not just for the environment, but also for youth. And they feel that. So they always welcome me to talk and have a chat. I also focused on women elders. As a woman, I'm very, very interested in the voices of women. Men focus mostly on voices of men. I find it extremely interesting, as I am an environmental economist and I listen to the voice of Mother Earth, to also listen to elder women to see what they have to give me as knowledge. And I would say for the rest, wait and see. And if partners want to get involved, I already took a couple of emails down. Follow us. We're going to have a wonderful time creating and hopefully exciting many youth in both America, Canada, and perhaps around other countries in the world to look at this hybrid model based on traditional indigenous knowledge and science.
Thanks, Pamela, for your answer. And I have a quick question about these interviews. Whether these interviews will be available for the whole research community later, once your studies are done, or?
Absolutely, absolutely. The aim is to also present at the United Nations during Indigenous Day. And then I also noticed that there were some folks who were linked with the European continent. What might be important to know is that I'm originally from Belgium. So obviously, we hope to disseminate these results also in Europe and open to all other interested parties for sure.
I just wanted to chime in quickly too that there's a National Science Foundation larger observing for traditional knowledge project called ELOCA. It's an acronym, but it's ELOKA. And the interviews have been transcribed and translated on that site and available for investigators.
Thanks, Martin and Pamela, for this information. I think it would be really interesting. And you have got a comment about the from Michael Raddy. He's looking forward to learning more about this work. And I think
Thank you. Thank
yeah.
you. Thank you so much, Michael, for your kind remark. And it was a pleasure to be a part of this wonderful presentation.
Likewise.
Yes.
Well.
Okay, so this is the last call. If Dimitri is still present and would like to present the work, because we have already finished all the posters. If not, I think we are almost on the time. And I was thinking we still have 4 minutes. Let's get a little bit more social because we are not meeting each other. Keep your video on so that we can capture the poster session picture maybe. Is it a good idea?
Yeah, of course.
Very good idea.
Yes.
So everybody, videos on.
Videos on, and I will take 2 or 3 screenshots. Yeah, so happy faces from the entire world.
If you stop screen sharing, then we'll be able to see more at once.
Screen sharing. You mean that I should share the screen of the video?
If you stop sharing the
okay.
share.
Yes, I can stop sharing. Yes.
Yes.
Yes, now I can see more faces. Okay, quick smile. Okay, so I think we are done with the picture. And
yeah.
We should have done something like this.
Thank you. Thank you for the panel. Bye.
Yeah. Okay.
Bye-bye.
Thank you, Miko, for your work. Thank you very much for supporting.
Thanks to everyone. We did a good job here.
Thank you. Bye-bye.
Thank you.
Bye-bye.
Thank you. Bye-bye.